Yeah, good evening, everyone. Good evening, good evening, good evening, good evening, good evening, good evening. Okay, I'm still waiting for more response. Okay, okay, I guess everyone can hear me. Yeah, good evening, good evening, good evening, good evening, good evening. You're all welcome to class. You're welcome, you're welcome, you're welcome, you're welcome. You're welcome to class. You're welcome to class. You're welcome, you're welcome, you're welcome, you're welcome, you're welcome. Yeah, so in the last class, we discussed a couple of things about backend development, and I know um, you know today's class is still going to be a continuation to what we've been discussing that since Tuesday. So yeah, today is just going I won't say deeper. It's just moving forward with what we have been doing. So yeah, the first thing we have on our table tonight is introduction to databases, basically. So the database we are going to be using MySQL, PostgreSQL, MongoDB. That's what we are going to be using. But this is just like an introduction. Okay, so this is just like an introduction to what we already have. So sorry. Okay, so it just gives an introduction to what we already have. So we want to discuss some SQL, PostgreSQL, and then MongoDB. So based on our last class, I know we did a lot of things like in the last class. I know we discussed about a lot of things. So I want to know, like, based on what you did in the last class, what do you like based on what we did in the last class? So what was your take? What was your take in the last class? Please let me know in the comment section. So I'm not. You guys are not saying anything. No, pardon. Think I've added it. Okay. Please, I asked a question already. I said based on what we did in last class, what's your take about what we did in last class? So I'm still waiting for our comments. I'm still waiting for our take on what we did in the last class. What you understand by database, basically. Shouldn't be something hard for us to do, since we've been working with them already. So it shouldn't be something hard for us to work with. Because last class we did introduction to backend and then so what's the take? I'm still waiting for our responses. I'm waiting so we can move on very quickly. Yeah, good evening, good evening, good evening. I'm still asking the question. I'm still asking the questions. database is storage, okay, place where data are kept. Node is not a programming language like C sharp. Okay, cool. Okay, so I'm still waiting for more responses, so I will know more response. You haven't gone through the previous class yet. Okay, so you should. We're talking about backend to be the process of building server side for web app. We looked at the difference between front end and backend server side, and okay, okay, cool. You guys did a lot of database is a place where data is stored and backend development involves the management of database. Okay, cool. Okay, cool. So let me ask a question. We have how many types of database do we have, and then you are going to mention them. How many types of database do we have? How many? And yeah, how many? Okay. Someone say we have two. Yeah, true. So we have two. Yeah, we have two types. Yeah. So we talked about between SQL and NoSQL data. Okay, cool. We have two. Yeah, we have two, and then mention the two. Mention the two. Okay, so someone's a query. Structured query language and no structured query language. Cool. Hmm. Two types of database. That's my question. No. So SQL and no SQL. Hmm. Hmm. SQL is structured query language, right? And then I asked like database. Like I'm asking two types of database. You're actually right, but what you could have just said is okay. Let me just help us so we don't waste much time. You could have just say relational database and non-relational database. That could have solved the whole thing. Do you get? When you say SQL, structured query language, fine, that's fine. You have SQL and then we have no SQL, but you can also do no SQL is no relational. Hmm? No SQL and SQL. No SQL. Okay. No SQL. Okay, cool. All right. So I want to ask another question. So basically, what do we use okay, I think what do we use APIs for? Or let me just say what are the requests? Yeah. Let me ask this question. What are the requests? What are the requests for when you are using RESTful API? What are the main requests you are doing? Let me just give you an example. One example is you can do delete. So can you give me any other two? You can do delete. Now I've given you an int like that. So any other two? Any other two? Okay, cool. Someone said get. All right. Put. Okay, post. Okay, cool. All right. So that shows that we followed the past class. Oh, cool. Get, post. Okay, cool. Yeah, cool. Insert. Okay. So we are fine, and then we are good to go. This just prove that we are good to go because I wanted to be sure if we are good to go for today's class. So yeah, we are good to go. So yeah, introduction to databases. Basically, we have no SQL and then we have SQL. So when we have MySQL is more like how do I put it now? It's more like a management system for SQL. SQL is a programming language itself. We have MySQL, we have PostgreSQL, we have a lot of the Oracle, we have a lot of them, which we are going to be discussing in the class today. So I think I can move to. So what is the database? Basically, you guys have discussed what database is on Tuesday. The database is an organized okay, a database is an organized collection of data that can be easily accessed, managed, and then updated. Databases allow applications to store, retrieve, and manage data efficiently. So basically, importance of database is just like every web or mobile application from social media to banking app uses database to manage users' data. You don't just want to have like you want to manage people's information. You don't just want to like once they register, their information is going elsewhere. You want to like have a way of managing people's content and people's data very well. All right, so we have types of database. So we have the relational database, which is SQL, like we all said. We have the non-relational database, which is NoSQL. So basically, SQL is structured, query language, structured data stored in tables with predefined relationships between them. That's what SQL is about. Because when you say something is relational, it means each data, they are all related to each other. Don't worry, we're going to be having I'm going to be discussing them like as we move on. So relational, basically, when we say something is related, that shows that all data are actually related. So you can easily manage them. Do you get? So you can easily manage them. An example of them is we have MySQL, we have Postgres as well. This is actually one of the popular ones. There are still more, but it's just the popular one you should know for now. Yeah, so we have non-relational database too as well. They have flexible data model, storing data in key value pairs, sorry, documents or graphs too as well. Example is MongoDB. So you can decide to use relational database, or you can decide to use non-relational database, but you are still going to be seeing the difference between them. All right, so relational database, basically, relational database refers to a database that stores data in a structured format using rows and columns. This makes it easy to locate and access specific values within the database. It's relational because the value within each table are related to each other. We said relational. So obviously, what we have here is just like each tables that you have in the database, each table in the database you have are actually related to it, like to each other. So it's not as if you have a table here, then you have then like one table actually has everything. No, no, no. The way we have it, we have a user table, we have a product table. I'm just giving you an example of it though. So we have a user table, we have a product table, and then we have order table. So if you look at the three tables I mentioned now, I said user, I mentioned product, and I mentioned order. So when you go to an example is when you go to Jumia, obviously your information are stored on a table which is called the user table. Now the product you are seeing on Jumia is stored on a product table. Now when you are making order, if you look at it, you are making order. If you are making order, you are making order with your information. That shows that you are relating with the product. So if you look at it now, that shows that the order table, the product table, and the user table, they are related to each other, because the action you are performing on the product table, it shows that it knows who is doing that action, who is performing that action. That shows that they are related to each other. And then when you make orders, obviously you don't want to make order, let's say you place an order in Lagos, and then someone else is getting information about your order in Abuja. No, it's not done that way. Do you get? So it's actually everything is merged together, so they are related. They can easily communicate with each other. So when you go to the product table, immediately you click on add to cart, it knows the user that is adding to cart. So you can see all those data are related with each other. They are related to each other, so they go hand in hand. Do you get? They go hand in hand. And relational database management system, that's RDBMS. So we said SQL is relational data. If you look at it now, I didn't mention when I said relational database, I didn't mention the programming language itself, the language itself in my explanation there. So the RDBMS now, that's the management system. The management system. So relational database refers to data within each table relating to another table, which is what I discussed earlier. So RDBMS is simply a software that manages relational database. Most relational database management system uses the SQL language to access the database. So now, what we are now talking about here is that the relational database management system we are now talking about are now MySQL, are now Postgres, because they are built on SQL, because you want to use them as a managing system. That's what MySQL means. So MySQL is not like, oh, the language. SQL is still the language, but now what you are using to manage that system is now MySQL, Postgres SQL. So now they might have they are related though. I mean, the MySQL and then PostgreSQL, they're actually related, but their queries might just be a bit different. You know, how you access some data might just or how you query them might just be a bit different. But trust me, they are the same thing. Yeah, they are the same thing. So it's not something you should really bother yourself about. Once you know how to write SQL queries, you should be fine with Postgres. The only thing you just need to do, just look for more information about PostgreSQL, how to do a particular thing there, and then how to work with their UI. That's main thing. And then if you are also using MySQL, the only thing you just need to know is how to use their UI, how to work with them. Basically, that's just the main thing. But you need to understand relational database, and then you need to understand that MySQL is the what relational database management system. That's for MySQL. They are the management system. But relational database are what we have, like the SQL. Do you understand what I'm saying? So um that brings me to, okay, before I even come to types of how DBM is, before I come to this place, I want to ask something now. So when I want to ask the question, I want to ask now is that I said, I mentioned SQL, I mentioned Postgres, I mentioned RDBMS, I mentioned relational database management system. You know, I said some are not relational, some are relational. So now my question is that, what's the difference between relational database and non-relational database? You know, I explained relational database now, that relational database works with tables and rows. So each table, they are what? They are related to each other. And I gave an example of a store, of a product order and then a user. And I actually I explained a way of bringing the three of them together. And I used Jumia for example, so you can actually understand what we mean by relational database. So before my question, basically just me answering that question, so we don't have someone asking that question again. That's why I'm asking the question, so I can explain it again better. Okay, so now, good evening. Okay, so I'm still checking our comments. All right, so now structured query language. SQL is simply a language that is used to, okay, cool. SQL is simply a language that is used to talk or manipulate relational database management system. So you can see SQL is the language itself. Now, the types of RDBMS, I said we have MySQL, we have PostgreSQL, we have SQLite. I said we have a lot of them. I just did MySQL and then PostgreSQL in the first slide. Okay, so we have Oracle, we have a lot of them that you can actually work with. We have a lot of them. The only thing is just that know how to use the management system. Do you get? So you already know that SQL is what? Relational database, right? And then the MS at the back, relational database, RDB database. Then MS is the management system. So you need to know, okay, which one? MySQL, Postgres, SQLite. No, you can just pick any of them. You can just pick any of them. Okay, so when we now say, I was saying something about tables and rows, and then I used example of user, and I used example of a user, product, and order. So now tables can have hundreds, thousands, sometimes even millions of rows of data. These rows are often called records. Let me just put it this way. When you are counting, okay, let me just put, no, we are not in a physical class. So let me just paint the picture this way. When I say rows and column, because what we actually work with is rows and column. So when I say row, you all know that what I'm talking about is horizontal, right? When we say horizontal, while columns are vertical. So when we say a record, that means a record contains rows and column. Do you get? So now a basic record is just like do fintech. Yes. Fintech companies, they use them. They have to use it because to manage their data. You don't want to, when you are signing up, obviously they have a table to receive money, right? And then when you are sending money to somebody, that means they have a user table. Do you get? They have a user table. So now that user table, they need to know which user is making the transaction. So they have a transaction table too as well. When you make transaction, you will notice that you can see all the transaction you've made in a month. Now that transaction, now it's a different table on its own. So you can't see, okay, digital coach now. I don't know if you are using, like, let's say for example, if you are using OP, I'm using OP too. I can't see your transaction details on my I can't see your transaction information on my own OP. It's not possible because now the way the database is, everything is related to each other. So now the way it is now is that I cannot view other people's information because the table is related. My user table is not related to your own user table. Do you get? We have a different ID, and the fact that we have a different ID, that shows that my own information cannot show from your own end. So you can't see what I'm doing, and I can't see what you are doing as well. Do you get? So my own information only revolves, like, it revolves around my own table, my own user table alone, because the user table is actually very important. Everything you are doing on the application, you are doing it from you are the difference between them is just that you are using the user table to identify who is making that transaction. Do you get? You are using the user table. Oh, who is making this thing? Who is doing this thing? Who is doing this thing? So the user table is actually, it appears everywhere. Do you get? It appears everywhere. So that's actually my few this thing there. So when we say record now, so record is just like a row, like one row. And you know that when you are I don't know if how we do it. I don't know if you handled a Google form before. When you Yeah, true. When you yes, because they need to query their database table. Yeah. So if you handle the Google form, you can either download as an Excel, you can download as PDF. I don't know, like different ones. You notice that you have a column for name, you have a column for surname, you have a column for date of birth, you have a column for phone number. Now you notice that it is the rows that is differentiating each user, each entry from each entry. Like row one might be my own information. That means my name on column name, my surname on column surname, my phone number on the columns phone number. Like that's for one. So now the second one might be for digital coach. The third one might be for, let's say, victory. The fourth one might be for formulario. Do you like? Can you get what I'm trying to say now? Don't worry, I'm going to, like, I have a table. I think I have a table on my slide that I can actually use to explain all this. Oh, good. So if you look at this information here, you can see I have employee ID, I have first name, I have last name. So all this now, this is column, this is column, this is column. So now this one like this now, that when you are seeing employee ID of 11, that shows one record, record 2, record 3. So this like this now is a record, this is a record, this is a record. So if OP if OP wants to query their data, sorry, their user their user table, what they just need to do is just like, let's say if they want to pick let's say they want to pick digital coach now. Digital coach, we have an ID, a unique ID. So now that unique ID, now the only thing I just need to do, write my SQL query. Once I query it and then say where user ID equals to so, that shows that it's going to bring all your information, like it's all your records. Do you get? So only bring your record. Do you understand what I'm saying there? Don't worry about what are keys. I'm going to explain what are keys. It's just so I can explain what I mean by rows and column, and then explain what record, what it means. Okay, so I said data types here. We have a lot of data types in SQL. Basically, you might just need to like go for that because this is an introduction class. So you might need to like go forward. Don't worry, we're going to go forward with the class on their data types, but it's not something very hard. Obviously, we are going to have integer, we are going to have some other things too as well. And I'm very sure we did that basically. You understand what I mean by data type. So it's not something very difficult for us. Okay, so what are keys basically? So a DBMS key is an attribute or set of an attribute which helps you to identify a row in a relation table. They allow you to find the relation between two tables. Keys helps you uniquely to identify a row in a table by combination of one or more columns in that table. In the below given example, employee ID is a primary key because it's unique. It uniquely identifies an employee record. In this table, no other employee can have the same employee ID. So if you look at this now, I'm just using employee to showcase this. So now in a company, each staff has their own ID. No staff can have the same ID. They have different ID. I think a better way to actually I could have done this table is using school setting. Each one user sorry, two students cannot have the same matric number. They will have different matric number. They cannot have the same thing. So now the matric number is what is differentiating each student from each one. So now if you look at it now from a school setting now, you can now see that when you are checking your results at the long run, you cannot be seeing somebody else's results because your own matric number is different from the other person's matric number, and then the results they are going to post will be based on your own matric number, which is your own unique identifier on that application. Do you get? Which is your own unique identifier on that application. Do you get what I'm saying now? So now on that user table now, that primary key, what I mean by primary key now is the one differentiating you. Do you get? Because you can say I can decide to use phone number as primary key, but doesn't really make sense. So now the way we have 11 1 1, the way we have 2 2, the way we have 3 3 shows that is the primary. Two students cannot have the same exactly. That shows that is the this thing, the unique ID there, which is what we mean by primary key. So that primary key is just like on that user table alone. What is differentiating one record, one student's record from the other student's record is your matric number. That is what is differentiating you from others. Do you get? Your matric number is your primary key on the user table, that is on the student table. We have results table, we have payments table, we have transaction table, we have a lot of table that are actually related. But now if you now look at it now, primary key basically are now on that user table. What is differentiating you from other students, which is your matric number. I just use employee ID to like explain the whole thing. Okay, so now I've explained primary key. A column in a table which helps you to uniquely identify every row in that table is called a primary key. This DBMS, database management system, can't be a duplicate. So basically, two rows cannot have the same primary key value. Is not don't you can you should not have it. And I'm very sure if you are using a database management system, that's let's say you are using MySQL, you cannot have a repeated one. It will automatically generate a new one for you. So it must for every row you must have a primary key for every row. You must have a primary key, because what is the essence of you being a student and then you don't have matric number? It doesn't make sense, because how do we identify you? How do they know that you're a student? How do they want to know, oh, you are a student of this so department? They can't know much information about you. So you must have a matric number. That one is very, very important. The primary key field cannot be null. That shows that it cannot be empty. You have to make sure you fill in something there. You have to make sure something is actually there. The value in a primary key column can never be modified or updated if foreign key refers to that primary key. You know what I'm trying to like communicate here is that you know that your matric number, you can't say, oh, I don't like the way my matric number is. Can they help me to change it? No, you cannot do that. Your matric number is not generated by by guessing. It's actually generated by the computer, by the system itself. So it's not like something you can just go there and say, oh, I want to change my matric number. Please, I don't like this one. I cannot memorize this one. Please change it for me. You don't do something like that. So you cannot, once you have a matric number, you cannot modify it. And obviously, when I say you cannot modify, that doesn't mean you cannot go and modify it in the database. But please don't modify it. Just leave it that way. Do you get? So you have to make sure that you don't touch the matric number. Like once it generates like your matric number, just leave it. Once it generates a user ID for you, just leave it that way. That's basically what primary key is about. And primary key is not just what you are going to hear, what you are going to could even it's not just what you're going to be used, what you're going to use there alone. You're going to use it in several places as well. But just know how the primary key works on a user table. That ID that is different, that differentiates you from other records, that differentiates one record from the other person's record, is what we mean by primary key. And I said earlier, you can use a phone number as primary key, but now you might something might come up that your phone number, someone might put in your phone number, like, so it might be the same thing. So you don't want to do something like that. So you want to make sure that your primary key is actually auto generated by the management system. Okay, so I've explained primary key safe. If you look at let me ask now, if you look at this table very well, which one is primary key here? Looking at the table that I'm saying here, look at the table very well. Oh. Which one is the primary key there, please? I think I duplicated my slide also. Please tell me which one is primary key there? Which one is the primary key? Let me know. I'm waiting. Oh. Someone said the student ID. Someone said email. Email. Okay. Primary key. Primary key. Student ID. Good. Student email cannot be email. Someone might make mistake. They might write the same email, but that student ID now you cannot have 1-1. It's not possible for you to have 1-1. There's a problem. You cannot have 1-1. Do you get? You cannot have 1-1. Student ID is what differentiates. So no, now that student ID now in a school settings is now the matric number. Is your matric number. Because I remember that I used students. Do you get? It's now your matric number. So it's not like so I'm saying, someone said email. I'm so shocked when I saw email. Okay. Everybody says student ID. That shows that we are getting what we are saying. All right. So what's now foreign key here? What is foreign key? So a foreign key is a column which is added to create a relation. Sorry, which is created to create a relationship with another table. Foreign keys helps us to maintain data integrity and also allows navigation between two different instances of an entity. Every relationship in a model needs to be supported by a foreign key. Basically, let me explain once and for all, because all the English is looking too much. Okay, so now if you look at these two tables here, if you look at it very well, I want you to tell me the difference between, we have two tables. what is the first table? What name can I call the first table, and what name can I call the second table? Look at the table very well. What name can I call the first one, and then what name can I call the second one? I want us to do that very the student. I don't know. Sorry. Look at the table very well. You can see one table we have science, we have English, we have computer, and then the other one we have student's name, student information. So what name can we call the tables now? I'm waiting. Nobody can have the same email. Yeah, nobody can have the same email, but they can put in. If I put in, if you tell me now, if you say okay, put in your email, I can put in your email. If I put in your email and then you've registered before, you put in your same email. That's not unless I want to make it unique. That's one thing. Unless I want to make it unique, that you cannot duplicate it. You cannot duplicate it. We've had scenarios that some people are using the same phone number, but their matric number can never be the same. That's just one thing. So first table is a relational primary contact table and subject table, department table and teacher table, course table and exactly course table and student info table. That's all. The first one is no, we've not even discussed foreign key. The first table is the department table. Okay, departmental course and student roster. Okay. That shows that we are already we have an idea of what we are discussing now about tables and the likes, about relational database. Now you show that you have an idea already, because all the answers I'm saying here, there's no right or wrong answer here. It just shows that you have an understanding, course table and student table. Exactly. So now if you look at the first one here, you will notice that you have department name. That shows that table can be a different table. That's a, in your school we have a table called course table. That's all the courses. They all have their own table, and then they are this thing. So now that on that course table now, 001, is it I've said it already. 001, 002, 003 is a primary key on this table here. 001, 002, 003 is a primary key. No, now if you call this 001, that shows that you are calling science. If you call 002, it shows that you are calling English. If you call 005, it shows that you are calling computer. Do you get? Now, the second table here is now the student table. I'm sorry, the teacher's table. Do you get? It's now the teacher's table. It's not student, it's the teacher. Sorry. Teacher's table. Because you can see that we have teacher's ID, first name, last name. So these are all the teachers in the school, like lecturers in the school. So you have like their the information, the B002, B017, B009. That's their what? Primary key that is differentiating them. Do you get? That is, this B001 David Warner is actually what? One record. This other one is a record. This one too is a record. That's Mike Brunton is a record too as well. So now you can say this is a record, this is a record, this is a record. So now this table now, we have a course table, we have a teacher's table. So now let's now look at how we can actually how we can relate the two tables together. Do you get? Because we said we are working with you guys are actually getting what we are trying to say now. So now you want to look at how we can actually relate together, because now look at it now. One teacher is teaching one particular subject, one teacher is teaching another subject, one teacher is teaching another subject. Do you get? So let me move to the next slide. So now that actually takes me to what foreign key is. So in this example, we have two tables, teacher and department in a school. However, there is no way to see which teacher work in which department in this table. Adding the foreign key in depth code to the teacher's name, we can create a relationship between the two tables. Now, if you look at it now, we have teacher ID, we have department code, we have first name, we have last name here. So if you look at this table here, look at this table very well. That which one is which one is the primary key? Which one? Because I've not really discussed what foreign key is to us. Which one is the primary key here? Can someone tell me the primary key here? Hmm. I asked for primary key. Oh. Hmm. 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 Look at the table very well. Look at the table very well. Hmm. I didn't ask for foreign key. I asked for primary key because I've not really explained what foreign key is. Okay, good. I see a lot of people actually getting this thing. So teacher ID is the primary key here because if you look at it, we are still working on the teacher's table because you can see teacher, you can see first name, you can see last name. Now, the only thing that is different here is now the department code. No, department code is not, it can never be the primary key because this year I said primary key when you are on the student on the teacher's table, primary key is what differentiates one record from the other record. Do you get on the teacher's table? Now you can see that we have teacher's ID, we have first name, we have last name. If you look at it, teachers have first name and last name. The only difference here is just that we added department code, which is what actually takes us to what foreign key is about. Do you get? So the teacher ID, no, the teacher ID is the what? The primary key here. The teacher ID is the primary key. Depth code can be the same. Very good, exactly. You know, I said something about primary key. Primary key cannot be the same. So if you look at depth code, you can see we have 2002. Now that shows that that can never be the primary key. You know, I was saying something that you can have two. You can have some people can have they might be sharing the same email. You know, it's not like you can have like you can create the same thing. No, no, no. You are not creating the same thing. You can just be sharing them and then input their data. Do you get like you have the same login to it? That's what I'm trying to say. It's not as if nobody can have the same email. Do you understand? So the teacher ID is the primary key here, while the department code is now the foreign key. You know that, let me explain from a good endpoint. You have two teachers in the same department. How are they doing, Samuel? Mm, mm. You actually got the whole point very right. People can share the same name too, exactly, so that cannot be the primary thing there. Okay, so now let me give it a cap here. So now when we say foreign key, basically, you know, if you are in Nigeria, 002 means they are in the same department, exactly. When you are in Nigeria, we use Nigeria passport, right, for everything we do. Now if you go if you go to, let's say you go to London, if you go to London there, what will they call you? You know, you are in Nigeria, they call you a citizen, right? But if you go to London, they call you a foreigner. Do you get? You are foreign to them. Now, the fact that you are foreign to them does not mean you don't have identity. Because when you are going there, you basically show them your identity of where you are coming from, which is Nigeria. You show them your passport, your Nigerian passport. That shows that you have an identity somewhere. But in that place, you are just a foreigner. Do you get? And when you are in that place, you have an identity too as a foreigner. I don't know if you are getting what I'm trying to explain here. Please, do you get what I'm trying to explain about the foreigner thing? When you are in Nigeria, you use your passport, right? They call you a citizen. But when you get over there, they call you what? A foreigner. Now in Nigeria, your probably your name, your NIN and the likes, they are your primary key here. But now when all those things get to that place, they will become foreign. They will become a foreign key in that place. Very good. Very good. A key from another table is foreign. But I'm just trying to like put it from an endpoint where everybody can actually understand, verify. When you are in Nigeria, we all have citizens table. Now something is differentiating you. You are what? You are a citizen here. But now when you go over there, they call you a foreigner. When they call you a foreigner, definitely you have an identity somewhere, which is in Nigeria. You have an identity in Nigeria. Now for you to go over there, they want to know where are you coming from. They want to know your identity first. That is why you have to have your passport. You have to have some basic information for them to identify you as a citizen of a country. And you know that if you don't have any identity, if they cannot identify you, they can't give you visa, they can't give you order, they can't even give you access to their country. They can't give you access to their country. So they want to make sure that you are a citizen of a particular place before coming over to that place. Now when you are going there, you are a foreign key in that place. It's just like when you are in your house, you are the king in your house. But when you get to another person's house, you cannot do anyhow. You cannot go to their kitchen. You cannot go to anybody. You go to somebody's house and then the first thing you do is to go to their kitchen. It's not possible. You are foreign in that place. But that does not mean you don't have where you are coming from. You are coming from your house, where you are a king, where you are a primary key. But when you get to that place, you are a foreign key. You are foreign there. Do you get? Now, let's now relate it to our table now. So now, if you look at this, like you guys have said earlier, 002, 002, 001, this year, they are what? They are foreign key. Remember that on their own table, they are primary key on their table. But when they got to this teacher table, they are what? They are foreign key. Now, when you reference this 002, you are basically referencing the what? The course table. Because 002 is a primary key for a particular record in course table. But on teacher's table here, it's a what? A foreign key. Do you get? That shows that, oh, that teacher is actually teaching 002. And what is 002? I think 002 should be, 002 is English. That shows that, oh, this particular teacher, sorry, let me go back to the next one. All right. So that shows that David and Sarah, they are teaching English. Those two teachers, they are teaching English. Probably they rotate it or something. They are teaching the same thing. So 002 is a foreign key here. That is, in a nutshell, any primary key on another table that finds itself in another table is a foreign key. Any primary key that finds itself in another table is a foreign key. Do you understand the whole difference between foreign key and primary key? Is that clear? Please let me know if my explanation is clear. I believe this will explain everything between foreign key, primary key, and the likes. Exactly. Okay, good. Quite clear. Okay, very good. I love the fact that it is clear to everyone. Yeah, I love the fact that it's clear to everyone. All right, cool, cool. Okay, good. Okay, so difference between primary key and foreign key. So basically, primary key helps you to uniquely identify a record in a table. I said in your own domain, you are a what? Primary key in your own domain. Do you get? But a foreign key is a field in the table that is the primary key of another table. Now, your foreign key here, your foreign key is a primary key. Like your foreign key basically is just like a primary key in another table. You are foreign in the US, you are foreign there. But in Nigeria, you are a king in Nigeria, you're a citizen in Nigeria. But in that place, you are foreign. That shows that you're a primary key here, but in that place, you're a foreign key. I believe. Cool. So now, primary key never accepts null value. That shows that they cannot be empty. Primary key cannot be empty. A foreign key may accept multiple null values. You can decide that a teacher can be and then not have any subject. You might not assign any subject to a teacher. You can do that. You might if you employ a teacher today, you might wait for like let's say you might wait for like a month to assign a subject to a teacher. You might just hold on and then just see how things goes on, and then explain to the teacher, okay, this is what you are going to be taking. So you can see that your foreign key, you don't have issues with it. It can be null, it can be empty. You can have the single primary key in a table. You can have the single primary key in a table. Non-teaching staff, exactly. But now, this shows that's just it. Non-teaching staff. You have employees. You have employee ID. Now, employee ID now, you have course ID. Now, all those non-teaching staff now, they are also employees too. Do you get? They're also employees too. So you can decide to add this thing to them. So I love the fact that you guys are actually getting the whole thing. So you can have multiple foreign I key, multiple foreign keys in a table. Obviously, when we are assigning teacher code, you can see we assign 002, 002, 001. So you can decide to apply, you can decide to say, oh, one teacher is teaching 5 subjects. Do you get? I know that's not possible, but you can decide to do that. Yeah, you can decide to do that. So I love the fact that we are getting the whole thing. So type of relationship, basically, I said relational database. We have one-to-one relationship, we have one-to-many, and then we have many-to-many. We have one-to-one, we have one-to-one, we have one-to-many, and then we have many-to-many. So if like in a practical class, we'll be able to like explain what each of them, what they mean, what each of them mean, like with the whole relationship thing. So basically, the let me just explain some of them randomly. So the one-to-one relationship is just like, when you register on Facebook, you remember that you cannot have 2 profiles on Facebook. You can only have 1 profile. One user, 1 profile. One user, 1 profile. One user, 1 profile. One user, 1 profile. Am I right? Please let me know if I'm wrong. Please let me know if I'm wrong. Oh. I'm just like trying to like so I can explain that too, because I didn't really in the practical class we're going to discuss more about the one-to-one, one-to-many. Okay, cool. Someone said yes already. So one user, 1 profile, one user, 1 profile. So that shows that one-to-one relationship. One-to-one relationship. That is your on user profile. We understand because we have a sorry, on you have the user table, you have the profile table. Now, one user can only have 1 profile. No, you can't easily switch accounts like WhatsApp. Exactly. One user can only have 1 profile. Do you get? That's what we mean by one-to-one relationship. Do you get? One-to-one relationship. There is nothing more with it. One-to-one relationship. That shows that on the user table, now when the user is going to the profile table, that user ID is now going to be what? The user ID is going to be what? A foreign key in the what? In the user profile table. In the user table, the foreign the user ID is the what? Primary key. But when the user ID get to the user profile table, it's not a foreign key. But now the one-to-one relationship between them is just that one user can only have 1 user profile. Do you get? They can only have 1 user profile. Okay, so the next one is one-to-many. One-to-many. So if I'm going to explain one-to-many, one-to-many is just like okay, yeah, cool. Let me use this to explain. One-to-many is just like one user. Sorry, one user can belong to. Okay, no, let me put it this way. One city. I don't know if a majority of us are in Lagos. Now, if you look at it now, we are in Lagos. Lagos is what? On a table called states. Lagos is on a table called states. Now, that state, now you can see that Lagos is just one. Lagos is just one. But now you can see that many users can stay in Lagos state. One-to-many. Many users can stay in Lagos state. That is one state can have more than, like, can have thousands of users. I don't know if you get the one to many that I just explained now. Yeah, like all your BVN, all your NIN, exactly. I don't know if you get the, sir. I don't have okay, I think I can have a table here. Don't know if I have a table here. Uh, but the don't worry, in the practical class we are still going to like explain more about this thing. Do you get? In the practical class we're still going to explain more about it. But please, the one to one relate like governor to Lagosians. Someone said like governors to Lagosians. That's funny. Yes, like governors, one governor to many people. Exactly, exactly. All right. So yeah, Nigeria is an example. Exactly, exactly. So many to many now. If you are now looking at many to many, I've explained one to many. So many to many now is just like one. Let me just say many. Let's say you have a product. If you have a product here, you have a product. You know that, yeah, I understand. Like one country exactly. Many the many to many this thing here. You have a product now. You know that many user can order that product. That is, many user can order like many of those products. So it's more like, okay, one user call for, let's say you have phones, you have on your website. Now on the customers now, many customer can place orders. If you know why I did not say order, many customer can place orders. Now when they are placing order, you can see that many customer, many orders, and many products. So now you can see that orders are many, products are many, customers too are many. So you can see the relationship there is what? Many to many. Okay, the fact that you guys are actually putting, taking, like, giving it context is actually making sense. The way you are giving it context, so you can actually understand it better. I love that. Thank you very much. At least you guys are actually getting the whole thing very well. It's many, exactly, exactly. So many to many, just like you have many, you can have many others, many products. Like, they can one many customer can order many products. Do you get? So you can like the toss soap to the users. So do you understand now? Like glow with different service they provide. Okay, 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 okay. Cool, 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 cool. Okay. All right. So introduction to SQL databases. I think by 8 we are going to go on a break by 8. So and then I know I cannot use 3 minutes to explain introduction to SQL databases. So we'll just you guys don't worry, you guys can just keep giving your view about like what we've explained. You can keep giving your view. Let me take it back to types of relationship. Okay, cool. So you can check it again, one to one relationship, one to many, many to many. So by the time you are starting it, so many users can buy the same Adidas sneakers. Exactly. And that Adidas sneakers now, it's going to be many. It's just that the products are many, main market and buyers. So you can also look at it, check them out. You get. So we are going to be going on a break by 8. Yeah, but you guys can keep putting your opinions about the whole thing. But I'm with you. Like, which one is one? Agbo again. Okay, so just 1 minute to our break. So you guys can keep, yeah, you can keep. So please make sure you fill in your attendance during the break time. So we are going to be back in the next 10 minutes. We are going to be back in the next 10 minutes. That's we are going to be back by 8:10. So yeah. So you're all welcome back to class. You're welcome back. You're welcome back. You're welcome. 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 Still checking our responses though. You're welcome. You're welcome. Okay. All right, all right, all right, all right, all right, all right. You're welcome back. You're welcome back. You're welcome. You're welcome. You're welcome. You're welcome. You are welcome. Okay, so yeah, introduction to SQL databases. So basically, we said I've explained a lot of things, a bunch of things there, and then tomorrow we are going to be having the practical aspects where we take you on how to like work with all these things. This is just like going to be like an explanation, an intense explanation though, so that when you are working tomorrow, we can't just say we want to keep it to one class. That's why we are doing all this intense explanation. So when you are coming, it will look like, oh, you didn't really gain anything. That's why we are doing the intense explanation. So you can get everything all at once. Do you get? Okay, so introduction to SQL databases. SQL, we all know that is a structured query language. It's used to interact with relational databases, right? It's used to relational database. Features of SQL databases, we have data is stored in tables. And when I say tables, that shows that rows and column. And you know that one row, one this thing, when I say record means combination of the rows and then the column, just like somebody's record, the user's record. It is strong ACID, probably we call it acid most times, acid properties, that is atomicity, consistency, isolation, durability, ensures data integrity. I'm going to be explaining that. Best for structured data with clear relationships. So when I say atomicity now, the reason why I said atomicity is that you know that when you want to register on Facebook, if you notice very well, you will notice that the first thing you do when you want to register on Facebook is that they ask for your email, they ask for your email, your password, and probably they don't really ask more than like four things. They only ask like for I think they ask for email, phone number, password, and then probably your date of birth. Yes, your date of birth, your date of birth, your phone number, date of birth, password, and name. Yes, I think those three things. They ask those three things. They ask for your name, they ask you for your date of birth, and then they ask you for your password. Do you get? Now, these things now, these are what you use in the registration process. Now, if you look at it very well, you will notice that they don't really, like it is when you get inside the app, that is when you start filling your profile. You don't start filling profile immediately. Did you notice that? Please let me know if you can relate it to what I'm saying. That's why I'm using Facebook, for example. Let me know if you can relate to what I'm trying to say. What I'm trying to say here. I'm not seeing any response. So name, password, and date of birth. Exactly. That's what they asked you. Okay, cool. You guys can relate to what they are saying, what they are doing there. So now all these things they are doing is to make sure that when we say atomicity now, that shows that we are trying to make it in the simplest form. Now that simplest form, now how do we now join everything together? That is where relational database now comes in. Because if you look at it now, there is nothing difficult in saying, okay, as an employee is coming out, that employee on that same table, we will put after opening an account, then you now fill the rest. Exactly, but you open an account first. That's your user profile. That's on that table. So now, as the employee is coming in, then you start doing, okay, as you're coming in, I fill in your name, I fill in your password, I fill in your department, all those things now. You don't want to do that because it actually it overwhelms the user. Because when I go to your website now and then you start asking me many questions all at once because I want to register, kilode, it doesn't really make sense. What about you follow the atomicity whereby you separate the tables? That is what Facebook did. Facebook separated the user table from the user profile table. They now use the what one-on-one relationship to merge them together. Because when you register, then you now start filling your profile. Now that profile has your user ID already. So when you are filling your user profile, he knows the user that is actually filling that user profile. So you can see where they did atomicity now. So that means you you can now streamline all the processes. That is, okay, you go to another table, you go and create ad, you go to another table to go and do so, you go to another table to go and do so, you get what I'm saying. You have another table to post, you have another table to comment, you have another table. Like, they've done everything in its simplest form. And then they now what they now did that they did relationship, um that is relating all of them together so they can maintain consistency. And also isolation is actually here too as well. Sorry. They isolate some data, durability and data integrity. Please, I hope what I just explained now with the whole atomicity and what I explained here, I hope it's clear to us, so we can move to another part. Please let me know if what I explained now is clear. Please confirm what I explained now is clear, please. Okay, cool. All right, so my basically my SQL overview. Yeah, my SQL overview. All right, so does the separation means exactly that is that separation now? It means someone say clear, sir. It means atomicity. That is, you made everything in its simplest form, so that the only thing you are just doing is just to relate them to each other. Do you get? That's just it. Okay, so basically my SQL is actually open source. Is open source. Let me say SQL basically is actually open source. The reason why you can see, if you notice, a lot of people are actually building on SQL. Like MySQL now, they built on SQL. PostgreSQL, they built on SQL because MySQL is a software. PostgreSQL is also a software. They are all building on SQL. Do you get? So it's because SQL is actually open source. So you can decide to go further on your own and then start building on SQL and then start doing some things and call your own. You can call your own. I want to pick somebody's name. You can call your own Cynthia SQL. You can call your own Happiness SQL. You can call your own Adiagbo SQL. Do you get? You can decide to call your own SQL. When you get to that stage, you can start doing your own. So it is widely used in web application like WordPress, Facebook. It's also known for performance and reliability. When you hear relational database, the first thing that has to come to your mind is MySQL. That's the first thing that will come to your mind. The next one that will come to your mind is reliability. And MySQL like this now, you might be hearing something like MariaDB and the likes. Do you get? Reliability. So use cases basically is actually ideal for application with structured data and complex queries. So MySQL basically can stand the test of time. Most big companies in the world, they use MySQL. Big companies, they use MySQL. You can see I had Facebook there as an example. They use MySQL. So companies with big, they have complex queries. And when I say complex query, when you do relational database, when you click on transaction If you are making a query, the query you are making is, okay, go and fetch this user. This user, which transaction is related to this user? Okay, yeah, fetch, yeah, display, palm to display it. You know all those kind of things. That's what we mean by complex query. So examples, websites, content management system. Basically, they actually use all these things to actually make things work better for us. Okay, so Postgres overview. So now Postgres, I said the SQL is open. You can start doing your own SQL. I said it earlier that you can start creating your own SQL if you like. I said you can call it your name, and then if if people in the cohort say, oh, that's my cohort member, oh yeah, let's start using that person's SQL. Fine. Okay. So PostgreSQL, so no, open source basically. So relational database is known for advanced features like complex queries, data integrity, and support for JSON, semi-structured data. So basically, what the thing is, how all these things are actually coming in is that the problem MySQL is not solving, like some of the few problems is not solving, that is what PostgreSQL now came to solve. Do you get? So it can sell. Like some of the few changes, they just did some few changes. So they can sell, they can have they can have audience. Do you get? That's what PostgreSQL too. That's what they actually came to do. So they can actually add some extra things to their own, so that people not say, oh, you copied the old. They added another one, just like stealing like an artist. Someone said in the class the other day, stealing like an artist. So that actually works, and then it's working for them. So advantages, basically it actually extends, supports custom functions, supports strong support for data integrity and performance with large data sets. A lot of large companies, a lot of big companies use PostgreSQL too. So use cases, application requiring complex data, e.g. analytics, financial apps. When I say financial apps, I mean like our fintech applications that we have in not in Nigeria alone, like all over the world. They use all these things. So it's not as if Nigeria only. Nah. Okay, so I don't know why this is very small. Why is this small? Let me make it a bit bigger. I'm not sure it can be bigger. I don't know. Why is this small? What's going on? Okay, I think you guys can see it's small. Please scroll down the page. Okay, sorry, that's not for me. All right, so creating a table. I don't know why this one is small. Okay, let me check it. I think I've made it bigger now. 18. Oh, I'm gonna have to refresh. I don't want to refresh my this thing. Sorry, you guys should help me. Please increase. I don't want to refresh the tab. So sorry about that. I've actually make it bigger. So what about Microsoft SQL? I said it now. I said you can decide. I can see it too. You can see it. Oh, cool. If you can see that, actually fine. You can. I said you can create your own SQL. I mentioned. I think I mentioned I said Cynthia SQL. If Chuku SQL, you can do Olabode SQL. You can decide to create your own. You can decide to create your own and then work with it. Okay, so some are saying they can see it clearly. Okay, thank you. All right, I'm just looking at it. It's not going to be small for you guys. Okay, so I've actually made this on a line though. So creating a table, which is actually what we are going to be doing the practical aspect tomorrow. So if you want to create a table, you can see that I did SQL example. I did not do my SQL at the Postgres example. And the only thing I just did is that I put them inside a bracket and I put MySQL and PostgreSQL. Now, what I'm writing here is what? SQL query. Do you get? What I'm writing is SQL query. Yeah, what I have here is SQL, sorry. What I have here is SQL query. It's not my SQL, be Postgres, it's SQL itself. So now my SQL now, they adopt all those queries in them. Do you get? They adopt all those the same way we used to have the way we have React use JavaScript in React. Abi, you write JavaScript in React. So that's actually the way this one is. But it's not like more like the same thing. I'm just trying to like, so you can have an idea of what we are trying to pass across here. All right. So to create a table, basically, we have that all programming language now, we have all languages, we have syntax, right? So now the create table here is what you first use to create your table. You write create, then what do you want to create? You want to create a table. What's the name of the table? User. Then when you say user now if you have ID here, you know that ID, I said serial primary key, that ID is going to be the primary key inside this place. Do you get? The ID is more like a, I would say one column, and I'm very sure you understand when I say column. Column is just like when you have name, ID, name, last name, like that thing at the top, the first thing at the top. Okay. So the first thing at the top, like the ID, the name, the last name, the phone number, and the likes. So the next one is name, and then the varchar you are seeing there is now the data type. That is, what can you do? Okay, the data is you can use data type of varchar. Varchar is just like a variable character, you get. So it's more like you can put your text there, you can put David, you can put any name you want to put. Now the next one is now email, which is also varchar. Your email can be text too as well, text and numbers. And then you now notice at the back we added the unique. I was saying something about being something unique. Now the only part, because it is unique here, doesn't make it a primary key. Because it is unique here, that doesn't make it a primary key. The only reason why it's unique here is just that we don't have repetitive users. Because one user can register with okay, me for example. Now let's say for example I want to register an account and I'm using the same number to register the account. It doesn't really make sense. Do you get it? It should not be like, okay, you have like one user is now having like two accounts with the same email, but now the only difference is just that their ID is now going to be different. But the reason why I'm making that email unique is just that so you don't have repetitive information. That is, that email you don't make it repetitive. If you want to log into your Facebook now, you can either log in by mail or you log in by your username. And I think you can log in by phone number. I think phone number too is unique. Phone number too, I think phone number is unique. So you can see that they don't ask you to log in with your user, your name, your full name. Because you know that one person can, three people can have the same name. So they will not ask you to log in with your name. They will not ask you to do that. They can only ask you to log in with unique informations. That is information that are unique. Like email, you can say I've put unique on the email. They did not, unique is not on the name, because obviously we can all have the same name. Two people can have the same name. Do you get? So that's why it is like that. So now that's about creating a table. Don't worry, you're going to see how you can actually create the table tomorrow in the practical class. So you can also insert to a table too as well. Insert to a table. If you look at it now, we use insert into. Insert into. Now, what do I want to insert? I said insert into. Now, what is the name of the table I want to insert into? I want to insert into users. I want to insert into users. Now, what are the information I want to insert? I want to insert name and I want to insert email. If you notice something, I want to ask in the comment section. Tell me what is missing when I'm inserting. Something is missing. What is that thing? Tell me what is missing in the table. Something is missing in the insert. Tell me what is missing. ID. So do you remember when I was saying that you don't create ID yourself? The management system will do the auto increment themselves. Someone say phone number. I did not put phone number when I was creating the ID now. The user. The ID now is now what? The primary key, which makes it unique. So you can see you don't create the ID yourself. the browser will automatically create the ID. If, for example, the first user is ID 1, the second person will increase by 1, which is 2. The next person is going to be 3, next person 4, next person 5, next person 6. So you can see that I did not put the ID. The man and the relational RDBMS will be the one to do that themselves. Do you get? So you don't do that. The only thing you just want to do, just upload the name, just upload the email. Do you get? So now you can now do select. You've created table, you've insert table, then you can also select from a table. That is, you want to let's say you want to get a particular thing. You want to get a particular someone say, wow, now I get. You want to select a particular user. So now we now use select. You use select from users. Select from users. Now, what is user in that statement? What is user there? Users. What is user? What is user representing? Someone should tell me in the comment section. What is user? What is user representing in the comment section? What's user? Oh yeah. Tell me. I'm waiting. No. What is users in that place? Someone say us. Someone say us. User is the table. User is the name of the table. Say us. So now in the statement now, that shows that what you are doing here is that you want to take all the user on your table, like all the user under that table. That's what you are doing. That's the query you are writing. Don't worry, in the practical class you will see how you can actually select a particular user. You can use some queries whereby you say select from user table, then you pick the person's name. You can say where name equals to Cynthia Odeji, then you press enter, then it will bring out that person's record. Now, when I say record now, I did not say it will bring out that person's this thing. I said it will bring out that person's record. Now, the record is going to bring out is that it will bring the person's first name, second name, email, like all those records that the person puts in. Do you get? Someone said the primary key is missing. The ID is now the primary key. I don't know if you are getting me. The ID there, because I said you don't add primary key. Do you get? The RDBMS will add it themselves. That is it. They will do the auto increment themselves. You don't tamper with it. Do you get? You don't tamper with it. That's what we are doing there. Because look at it now. When your school or when a school is putting in student record, it is the system that creates matric number. It is the system that creates matric number. You don't put in matric number when you are registering a student's name. No, you don't. You put in the student's name, then it will generate a matric number for that particular student when you are registering that student. Some people say some of you are data analysts. That means the SQL class is going to be very interesting for you. Yeah, the SQL class is going to be very interesting for you. Don't worry, tomorrow is a practical class. You flex your muscles tomorrow. You flex your muscles, you ask your question, and the likes. You flex your muscles tomorrow. But today, at least, I just explanation about everything, so we can know what we want to do. Then when we now come tomorrow, doing it, it will not look like magic. It will look like okay, that's what we were discussing yesterday. Do you get? Someone say about job. Okay. So now let's move to the next one. So introduction to NoSQL databases. NoSQL database stands for not only SQL. You get offering flexible ways to store unstructured. You can say that this one is unstructured data or semi-structured data. So features of NoSQL: schemaless. When I say schemas, now I mean tables. That table that I was showing that time is just schema. It's same thing as schema, so it's not one kind of this thing. So it's schemaless. There's no table. Do you get? Allowing for dynamic data structure. It's a bit dynamic. I don't really use NoSQL. Do I use SQL most times? Why do I say most times? I use SQL most all time. Let me put it that way. I use SQL all time. YouTube needs to update this site though, so sticker can be used. Hey, I won't use stickers. Okay. So we said there are no sticker. How am I saying there are no sticker? No SQL this thing. You people comment section. Okay, so yeah, allowing for horizontal scaling can handle large amount of data easily. Can take a lot of data without this thing. The one thing is just that, when you are working with NoSQL, when you are working with SQL NoSQL, you are not really running queries that will slow down your application, because the reason why most people, or let me say most companies, why some people's data are very slow, is that they didn't really structure their database very well. If you structure your database very well, running queries like I couldn't mark it, Mr. David is very so like running all these queries, running them like this now, it might slow down your application a bit, because you are getting information from this table, from this table, from this table, from this table. But if you not optimize it, it will not really work very fast. That's why some people just go with MongoDB immediately. Do you get? So this one is actually best for application with rapidly changing data or large scale data storage. A lot of companies too, they use NoSQL too as well. They use NoSQL, but most companies too use SQL. So it's they are both the same. Okay, so now MongoDB overview. So is NoSQL document-based database. You can just, there's no relation, there's no nothing. Store data in JSON, like and I'm very sure you understand when I say JSON, you understand that I mean objects. It stores them in objects. Do you get? It stores them in objects. Advantages: schema flexibility. Data fields can differ from document to document. Great for high performance and scalable applications. It's actually very, very fast. It's fast too. It's fast. Use cases: real-time analytics, content management system, IoT application. I'm not like those that actually use all these things. So you can use them for pretty anything. You can use your SQL for. Do you get? You can use it for pretty anything. You can use your SQL for. All right. So NoSQL example, which is a MongoDB, inserting a document basically. So what you want to do is that you put db dot users, which is this thing, the database name. Sorry, the table name. Like, but you know that we don't have table here. But I'm just trying to like relate it so you can understand what I'm saying. So now when you say insert one like this now, or you can see that this looks like object now. Look at, you can have we have something called key value pair. So you can see this is a key, this is a pair. Key value pair, key value pair, key value pair. We have a key, we have the value. This is a pair. A. This is a pair, this is a pair, this is a pair. And then if you want to query it like this now, we have something called find. So you can use db.users.find. So you can say if age, like where age like this now is 20. All those things, like just like get a particular set of age out. That's what you use this query for. Okay, I'm just trying to see if we have comments in the comment section, and also make sure it's fine. Okay, so comparing SQL and then NoSQL. So the feature is just that the data structure. Data structure. So in SQL, the data structure is basically using tables, which is rows and columns. That's what we use, rows and column. Then NoSQL, which is MongoDB, we use JSON-like. So in terms of schemas, so it's fixed, predefined schema. That is, the table is fixed. When you want to, like, you remember when we wanted to query, we had to go and use from query to from users to a particular place. So it is predefined schema. The tables are predefined. This one is flexible, dynamic schemas. It's actually very dynamic and flexible. You can decide, you can query it however you want to query it. Do you get? So scalability. This one is vertical scaling. This one is vertical scaling, and then this one is horizontal scaling. The two of them they actually work very well. They work very, very well. Very well. So use cases, we have structured data, complex queries, This one is structured and then complex query. This one is rapid development and large data sets. That's just like that's grammars. Let me just put it that way. That's just grammar between the two of them. Okay, so when to use SQL and NoSQL. You use SQL, that's MySQL and Postgres, when data is highly structured and relationships are well defined. When relationships are well defined, obviously you don't have any you don't have any business with NoSQL. You just go with SQL like that. You use strong data consistency. When you need strong data consistency, like your all this your what's it called fintech and the likes, like financial application, make my data like my money no go deposit for another place. Like you need you know strong data consistency. You make sure that you use like a structured query, I'm sorry, a relational database. Do you get? You use SQL basic sorry, no SQL. Basically, when you need flexibility in data storage, you just want to be flexible. Probably you don't really have much this thing. You are not handling people's money. Let me put it that way. You're not, but no, you can also use it like that though. But when you're not handling people's money, when you're not handling people's like you can, but it's actually very cool. So you are working with large data sets or unstructured data. When the data is not well structured, it's almost I'm encouraging myself in the Lord. When you have like unstructured data, you can go with NoSQL as well. So my conclusion, we are going to be having this in tomorrow, a practical class tomorrow. So everything we've discussed now like this now, please watch it over and over again. So tomorrow we won't be going back and forth and then start explaining what create table or this thing. Once we explain it once, everybody's going to get it once. So it will look like we'll go, we'll come back, we go, we come back, So because tomorrow is just the only class for SQL. We used to be over 1K at the beginning. Now we are 72 on the good day. This one. So tomorrow we are just going to go straight to the point, go to the what's it called, do our practical class very well, show us how to create table, how to query, that's how to insert, basically how to insert and how to do like other things. So make sure that you go through the class, today's class, because we'll be explaining everything that you're going to be like, you will now understand that okay, this is why we are using this is why we are using this, why we are using this. The class is just one class. So that one class, please make it count. That today, after the class today, you can just sleep, and then tomorrow, make sure you read up on all these things. Watch the video again. Try to understand this thing, and also make sure you as you are learning it, make sure you picture like you put in a picture like, oh, this is actually how they do this thing. This is how they do it. Like you picture things before the class. So now when you start the class, when you start the class tomorrow, it will just be like it will be easy peasy for you. Do you get? It will be easy peasy for you. So it won't look difficult to you. You already understand. So SQL database, MySQL are best for structured data and complex query. NoSQL database, that's MongoDB, are ideal for flexibility, large-scale application with unstructured data. So understanding the right use case for each database type is key to building efficient application. You get? It's key to building. You can decide to, when you are working on a project, you can, just picture everything, and then okay, which database am I going for? Am I going for SQL, or I'm going for NoSQL? So you can decide to, weigh them. After weighing them, then okay, this is my take, this is my pick, this is my this thing. So you can decide to explore too as well. I'm not saying you should not explore SQL, explore NoSQL. Also, tomorrow, before tomorrow too, I will really advise us to so that the practical class is going to make sense to us. I, okay, we are going to share the material, don't worry. So the practical class is actually going to make sense. You need to download you can download XAMPP or you download WAMP. XAMPP, WAMP. That's when you are using, or you can download, like you can try to download MySQL Workbench. You can try to download MySQL Workbench. I'm just trying to look at the one that can actually that can be easy for us to like work with. You can try and look out on XAMPP or WAMP. Try and look out on MySQL Workbench, and also you can try to download PostgreSQL. You've seen the name already, so you know XAMPP. I don't know. Digital coach, can you hear me too? XAMPP. XAMPP, and WAMP is WAMPP. That's if you are using WAMP if you are using Windows, but XAMPP is actually across. You can use it on iOS. I'm sorry, it's iOS now. You can use it on Mac, and you can use. Thank you very much for putting that. XAMPP or WAMP, you can download that. Also, you can work. Someone said Workbench is easier. So you can download MySQL Workbench. I think that person is a data analyst. So that person, yeah, that person is Zeribe. Okay, Zeribe. Sorry, I spoiled the name. All right. So you can download Workbench if that's actually don't forget that some people are active. Okay. So trying to. Someone said okay, and also, so you can do. We have already downloaded XAMPP. Oh yeah, now some people say they already. So now that you download XAMPP, my advice is just that to prepare for tomorrow's class, you can go online and then look for any database. Like just search for a simple database that you can run SQL query on, and then download the database, put it there. Do you understand? No, no, no. You can decide to. That's why I gave three. You can decide to download any of those, like any of them. You can decide. You can do XAMPP, you can do WAMP, you can do Workbench, and also that's for MySQL though. That's for SQL when you want to use MySQL. Those are for those. And also you can decide to do Postgres too. If you want to like be strong in all these things, you can decide to use Postgres too. So tomorrow we are going to like discuss how to work with MongoDB too as well. How to work with MongoDB. I think we're going to discuss that tomorrow too. Because it's going to be a practical class where we discuss the SQL part and the NoSQL part. Someone said we will finish well. So that will be the end of the class today. So please make sure you do all these things too and go through the video. Okay, okay, okay. Yes, when you are working with PHP, you down yeah. Was that we we download? I don't know if okay, let me check. If I can, I think I downloaded one today. I downloaded XAMPP. I don't know if I can share it on the Telegram channel. Once I download Telegram on my laptop, I'm going to see if I can share that. If I can share the XAMPP, or probably I will share the link how you can actually download them. What are we to download? You can download either XAMPP or WAMP or Workbench. MySQL Workbench. You can download any of those. Just to prep us for tomorrow. Which one will you use to teach us? Someone said which one we used to teach us. We can use XAMPP. We can. It's still the same thing. The only thing is just that the only difference is just the query. The query is just the same thing. So everything is the same thing. So, or let me just the only difference is just going to be the UI. Yes, let me put it that way. It's just the UI that is going to be different. It's just the UI. And when I say UI, obviously you cannot expect the same UI from XAMPP and then the same UI from this thing. But if I'm able to get my Telegram working today, I would see how to send. I think, can you share the link to? I'll share the link to download all those things. Someone said Workbench is simple, Abi. Oh yeah, everybody should download Workbench then. Okay, so you can download Workbench. Someone said, is this XAMPP or yeah, it is XAMPP, 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 XAMPP. Which one are you recommending for us to download? You can download Workbench. I actually use Workbench and I used XAMPP. See, just you can download XAMPP and WAMP. Sorry, Workbench and XAMPP. Yeah, just download um, Workbench and XAMPP, so you guys everybody can be on the same side. So yeah, I need to go now. So um, yes, you can download it too. Anyone, you can download it too. So I've said this will be the end of the class today. I've said it 2 times. Okay, occupies too much space. Someone says that occupies too much space. Yeah, that's true. So yeah, so we are going to meet tomorrow. We are going to have another class tomorrow.